Okay, so, wow, crowded room. So thanks for having us to give you some insights into some stuff we do at Google and what we do with big data, and some stuff about innovation and growth. So my name is Jens Bussmann. I'm the first Jens that will speak to you today. So we tried to keep it easy for everybody who has to listen to us. So we have the same first name, so you just have to remember one name. I'm with Google since a little bit more than 3 years, and I run cloud platform at Google for the DACH and CE region. So DACH stands for Germany, Austria, and Switzerland, and CE Central and Eastern Europe. So everything we do around cloud platform, all the products we have at cloud platform, all the solutions we have, that's what I run for the region. And maybe Jens can say a few words about himself. So I already introduced me. And maybe for the agenda, to do this first, I will talk a little bit about what big data is, my point of view or Google's point of view, how we look at it, how we use it, or how we mentor people to use it, how we suggest that you work with big data and where you can find value. And then Jens will go into a little bit more detail, like what the technologies are that we are using and how you could use them to work with big data and make use of it.
You said that?
Yeah, you already know me.
I'm the other Jens, and I'm a solutions engineer on the cloud platform. I actually found out this morning that I have my 7th anniversary at Google today, so I've been 7 years in Google. Started as a network engineer. I know a lot about Google's global infrastructure. I could talk about this for hours, but I won't. Maybe a little bit in the second session, but nothing actually in the first. And since 1.5 years, I'm on the cloud platform. All right.
Cool.
Back to you.
So is it better that side or the other side of the screen for the cameras, or you don't care? I'm going to go to that side. It's easier for the computer. So if we talk about big data and what big data is, generally for me, there is 2 trends or 2 things that really influence the big data trend, if you want to call it big data. Everybody calls it big data. It's just like the increase of data and what you can do with data. So the number one that I see is that because of mobile and because of computers becoming more and more mobile with the smartphones and the tablets we have, data points and data collection more or less happens everywhere, and uses of, or potential uses of data are also everywhere. So if we look, this is just mobile. This is not something that I would still call a trend, because people say like mobile is the next big trend in computing and where we do stuff. It's already a fact. There's some stats on how many devices are used, what apps are used, and how many Android devices are activated. But it's so massive, it's more than desktop computing already, that I would not say it's a trend anymore. It's a fact that we have. And the second thing from access everywhere is the everything part. So I think this is a trend getting started, that we see everything that could be connected to the internet or to any network is going to be connected, and it's starting to get connected. So we look at cars, there's more sensors into cars, and those cars are being connected to backend systems to get more data out of those cars and work with that data. There is other stuff like we just have, I think we just have started this week or next week, the international, what's it called, IFA, like the European Expo for entertainment industry and consumer electronics in Berlin. And they're like, connected home is a big trend there. So like everything that's in your home can be connected, your doors, your lighting, your refrigerator, whatever, and controlled by an app and optimized by smart apps and so on. So everything gets connected, and what we think is in it for in all those data, what we're looking for is to build what we call a digital and physical knowledge graph. So probably most of you know that we're like the Google knowledge graph, and what pops up if you go to google.com and you enter a search query, there's like this little box popping up on the right side that gives you more contextual information about what you're looking for. So let's say because I just learned yesterday that it's a very current topic. So if you Google Barack Obama, then there pops up a box with Barack Obama, and we do suggestions like other people also look for George W. Bush, or look for, I don't know, whatever else, and also look for Michelle Obama or whatever, and we give you like context around it. And that's what we already do in the digital world, and we're trying to mix this also with the physical world. And to build a real knowledge graph about everything that's anyhow connected, and you can get information about. So that's what we as a long-term vision are looking at if we're working with data. If you look more into big data and like the definition that most of the people I speak to have of big data, we usually turn to Wikipedia and see like what's big data and what does it really stand for. So for Wikipedia it says it's real data sets, it's large data sets, they're too complex to manipulate and to query with standard methods or tools. If I ask, so I'm not only talking to developers in startups, I'm also talking to like large enterprises as well. So if you ask CIOs in large enterprises what they think of big data, it's generally, that's the kind of definition they have. So it's more or less the same definition as Wikipedia, but it's like, we cannot use the tools we used to have to work with those huge data sets. The databases we used to work with for the last 10, 15 years, they just don't scale for big data, for those huge amounts of data, to analyze them, to keep them. Storage growth is so big that we cannot keep with that the traditional tools and methods that we use. If you ask somebody in Google, that's probably the more or less typical kind of answer that you get. So it's like something like, oh, that's an interesting problem, an interesting challenge. So let's get at it and look if there's something we can work with or invent that makes us happy to tackle this challenge and that makes us successful in working with those data sets. That's the kind of mindset that usually we have if we look at any new challenges, and big data is just one of them. So we try to build stuff that just works with that, and we're not trying to say, oh, there is nothing out there, so what are we doing? And like, just not doing anything. And why are we doing this, and why do we think it's important? Because if you look at data, and Google is a very data-driven company, we think there's a lot of advantages, and I've just put a few advantages out there. But I'm a firm believer that the more you know about whatever you do, be it your customers, be it your business processes, be it your supply chain, be it your manufacturing processes, whatever, the more data points you can gather, the more data you have, and the better you can analyze those data points, the better you will be at doing what you do in this process. So you can be proactive in addressing any concerns in your supply chain with your suppliers if you see this data coming in early, if you can analyze the data coming in early, and if you see trends from this data early. If you're just reactive, you're probably also at a competitive disadvantage. You can optimize your business processes, you can mitigate risks, and so on. So this is like real areas that create business value for you as a company, why you should look at data more in a more thorough way. And what do I see, or what do we see as key drivers of growth of big data? It's probably those three areas. It's the availability of data, and I've already spoken about that. There's a lot of devices and sensors out there, and you get even more data points, and you will get even more data points in the future. So there's a trough of data out there that exists now and that you can dig into, and you have access to way more data than you had in the past. Also, the ability to process is increasing. There's new models of how you can work with big data. There's new tools. There's new technologies. There's advances in hardware as well as in software. And it makes it easier to work with big data. Stuff that was not possible like 5 years ago, or maybe 10 years ago, even 3 years ago. There were problems that you could not tackle with technology available at that time. And then there is what I think really helps for people and companies at every size to work with big data, that there's now cloud consumption models that really help you to start with those problems without being a large multinational corporation with big checkbooks that enables you to buy huge clusters of computing power and huge database clusters to even start working with big data. Everything now is on demand. You can get access to resources that we at Google use, that other IT giants in the market use, and you can use those resources yourself without any upfront investment of large amounts of money, which was probably not the case even 3 years ago. It was very nascent, and now it's coming of age. So now that I've tried to give you my idea about big data and why you should look at big data and why it's a competitive advantage to work with it, how should you actually work with it? So, because everybody says big data, and big data, like, if you go back to your companies and ask, like, I don't know, senior management if they think of big data and if you should look at big data, probably everybody says yes. but nobody has an idea why and what and how to really do it. The advantages we've already spoken about, and this is like, you should always keep those advantages in mind if you look at big data, because you should not look at big data just of big data's sake. Because just you can do stuff, and because just there's technology to do something, that's not the right reason to do it. You should always keep in mind why you're doing it and what the end result should be. So one point could be you want to have a single view of your customers or of your processes. So you want to combine different sources of data that you have, for the first time merge them all together and do analysis on all of those resources that you have, and probably in real time, and probably also do some predictive analysis and so on. Okay, how do you get back? Does it still work?
Just minimize that. Minimize the window, and it's behind that.
Okay, cool. And always keep in mind that it's the basis for more informed decision making. There's also statistics that really underline that there's value. So there's a statistic done by two folks from the MIT, that if you look at top companies and companies that are data-driven, they usually have higher productivity and are more profitable than comparable peers. So it really pays off if you look into it. It's not just something that we at Google find cool and that we do. There's been studies about this, that if you're data-driven, you're more successful than people that are not data-driven. Usually people think that experience and like your gut feeling about making strategic decisions is extremely valuable and it's not replaceable by anything else. There's probably truth to it, and you cannot like disqualify experience, but decisions solely based on experience without data are way worse than decisions that are funded in data, and then somebody makes a call out of experience on top of those data points that they have. Yeah, and then it's like probably what everybody in Google has to do if you want to get a decision in favor of you. It's like most people say, like this is the kind of saying that works at Google, like in God we trust, but everybody else has to bring data. So if you don't bring data to support your opinion, you probably will not get a decision in favor of you. Even if everything sounds logical and you're good in convincing people, if there is no data to back it up, you probably will not get a decision in favor of whatever you're asking for. Maybe we were a little bit extreme, but that's how we work. And this is just two examples where we use data to make some decisions. Just like, it's not business critical stuff, but we do use data for everything. So one thing is analytics that we did in HR. So we did look in HR, we did gather all the data from all the reviews we do over the year, over a couple of years, and looked like what actually makes a good manager. Like, when do people say they have a good manager? What is the traits that you have of a good manager? And there's some assumptions that we had, but in all the data and analyzing all the data sets, we found some really proof points that we didn't have, that you would not think of, that makes a good manager, and now we are recalibrating the manager training to incorporate those proof points. And I think the even stranger example where we did use extensive data is on the right-hand side. It's an example from the New York office at Google. So to like support healthy living at Google, we did a study, I think, over 18 months to see why people are eating what in the offices. So maybe everybody knows that Google is famous for all those micro kitchens that we have, and there's like food more or less everywhere, and like it's not allowed, I think it's not allowed to be further away from your desk than 100 feet. There needs to be some food 100 feet around you somewhere at Google. And usually the saying is that once you start at Google, in the first couple of months you gain like 15 pounds. Because like food is everywhere and you're not used to like having that much food. And the thing is like looking at, okay, why are people like, and we give different choices. You know, so like you can get fresh fruits, and you can get chocolate, and you can get energy bars, and all the kind of different stuff. And the thing was like, what are people eating? And we did an extensive study on that. And then we'd also check, why are people eating what they're eating? And why are they not eating more healthier food? And it turned out in the end, if we just place food differently in the micro kitchens, people eat differently. So now we put like non-healthy food like M&Ms and chocolate in red bar, like it's red glass bowls. So because like now they look red, whatever this changes, I don't know, like they put in a different space in a red bowl and people are not taking stuff from a red bowl, they use the green one and the bright ones. Whatever they do it, but they do it.
I have a question.
Yes.
Do your employees actually know that you have some experiments and playing with data and collecting?
I think probably not. So I mean, huh? You do? So I don't think that I probably we do some studies, but not exactly what we do around the workplace. Otherwise, it would be screwed. You know, like if people know that we tell them we're looking like if you take like the green or the red bowl, it probably influences your decision. But I think we do generally inform people that we're tracking some stuff that we're tracking.
But we're also not tracking who takes what. We're just tracking anonymously over the aggregated data how much of the food goes down.
But it's like, so, you know, as a very exaggerated example, like even the point that we do track, like what people eat, like as snacks, shows that everything that we do is very data driven. And actually, like after changing that stuff, people now eat more healthy in the New York office, and they get way more fresh food and way more like of those fruity energy bars than they did before. And I think the consumption of M&Ms and chocolate went down by 2/3 in the office. So extremely, extremely down just by changing some bowls colors. So actually, what I tell people when I talk to them now with those examples is, if you want to have innovation, it doesn't have to be like just like little things like food, but real innovation and real insights. We believe it's all driven by questions. But the hard part is you have to ask the right questions, and you have to build the right models to work with those questions and with the answers you get. And that's actually the harder part. But how do we do it, and how do I suggest people to work with it? So first step, I tell everybody is understand what kind of data sources you have and how you can plot them along different dimensions. So look at what you have from internal sources of data and what you have from external sources of data. And I've just plotted a few examples on the chart. And then look if the data is structured or semi or unstructured that you have. And then make sure that you understand where the data source and the data you work with fits into that graph. Because believe it or not, a lot of times I talk to people and they get really confused if the data source they have is structured or unstructured, how they can work with it, if it's an internal data source they have or they might need for their experiment, or if it's an external data source and how they can get access to it, and then which tools they should use to work with it, because they are not really clear about in which quadrant the data source fits into. Once you know this, we believe that you have to store and instrument everything. So get as much data as you can, try to track everything that you can that is important for that, not even that it is important for the process. Maybe you don't know now if it's important or not. But if you're not tracking it now, if you're not storing it now, if you realize in 6 months or in 18 months that this data set or these data points might be important, you've already lost the data, you've already thrown it away. So whatever you can track, whatever you can store and instrument, do it. There's just an example that it's now possible to do it at any level of the business process you want to do this. This was an experiment we did last year at I/O, which we called the Data Sensing Lab. So we put those sensors, and I think, well, it's not real size now, but it's like, they were like this big. And we put them all over Moscone Center where we had I/O, and we could measure temperature and pressure and radio frequency and motion of people and air quality and all that kind of stuff. And then we did real-time analysis of how people moved inside Moscone Center, how temperature changed if people moved from one room to another, how radio frequency changed if people moved with their smartphones from one room to the other room, and all that kind of stuff. And it gave us a lot of insights into how the dynamics of people are during a conference and during different sessions that we do. Not sure what we did with that data and if we changed something for this year, but it just showed that we could take all the data points and also analyze them in real time. And setting up an experiment like this with all those sensors, from a technical perspective, from a engineering software development perspective, setting everything up just took a mere more or less 2 weeks. And then we could instrument all this due to the use of the kind of technologies that are available today. So if you have all those data points, if you have everything stored, what's the next step? Usually the next step should be you should create hypotheses and then build data-driven experiments around those hypotheses. So I don't think that we at Google, and probably nobody else, has the answers already up front and knows which questions to ask to get to the right results for their experiment. So what you should start with is a business objective. So let's say you have to, one business objective could be get better insight into your supply chain and be able to react earlier to, I don't know, volcanoes erupting in Iceland and what this means for your supply chain if planes cannot fly from A to B, or whatever, stuff like this. That's the business objective that you have. And then you build some hypotheses. What influences that business processes? What are reactions that might occur and what are the causes for that? And then you build models around those hypotheses and then you validate or discourage them with data. And you work along those lines as often as you need to until you can confirm or reject a hypothesis. And you work with different models to prove that the hypothesis is not just confirmed or rejected due to the model you built, but it's confirmed or rejected by working through different models, because maybe your model is screwed and that confirms or rejects your hypotheses. And that's a process, and you do it more over and over and more often, and that's why I think and that's the important part of technology that we have today. A couple of years back, there were no tools that enabled you to do this really as a process and do it over and over and in real time, because most of the tools you had, if you would have worked with a big data set in the amount of petabytes of data, you could probably do this, once a week, once a month. And if it takes you a year to work through this process, it's probably not value for your company anymore. But if this just takes you a couple of days, you can do this and you can iterate on that. And that's the important part, iteration. So we don't think stuff is perfect from the first time you do it. And one good example is, I would say, Android. I think we're getting to a state with Android where we're pretty happy with it, and it's an okay-ish operating system for mobile devices, I would say. But probably the first iteration of Android wasn't. But the idea at Google is moving fast is better than moving slow. And if you can move fast and if you can iterate fast, this is better than moving slowly, but moving for something perfect in the first step. So the idea is launch and iterate, work with all the data points you gather, analyze those data points, and based on the results you get, iterate on your product, iterate on your process, iterate on the ideas you have. So one example where we did this is Google+. We launched it very quickly, and we iterated very fast. So the team launched about 100+ new features in the first 90 days without any interruption to the service and with improving the service constantly on a steady flow. That would be from my side, to give you like a little idea of how I look at big data and how I advise people to look at big data themselves and how to work with that. And now to give you some idea, like in the tools that we use and the tools that you could be using, Jens will show you what we have, what we use, and how you can build on some of those tools. So thanks for listening and enjoy the more technical part now of the presentation. Cool.
All right, thank you. So yeah, I'm the tech guy. So I'm basically going on what the Google Cloud Platform allows now to use for you to make use of big data in different ways. There's a few different ways to do it, and we kind of have also a vision of how people should be able to use it. And it's not that we think there's definitely one right way. Actually, right there we show that there's different services you can use. One big part of big data for us is the open source community, because maybe like 10 years back Google did a lot of, well, let's say most of the innovations in big data space. Now it's a huge market and lots of people do innovations. So we need to also pay tribute to that, and we say You should be able to use any software, do any kind of analysis you want, and the platform we have should be the best for all of that. But then on top of that, we have our own tools. One is BigQuery, which I will go into a bit as well. And to save all that data, we want to have the best storage services to save all that data at a reasonable rate and have it integrated very quickly in all of those tools. Yeah, but when people today think of big data, they mostly think of this guy. They think of Hadoop. That's what most people have a lot of experience in when they already tried out something in big data. And if you want to hire anyone who knows how to manipulate big data sets, probably you're looking for a Hadoop specialist. And that's good. And if you think about how Hadoop started, it all started with this, which is the MapReduce paper. It's a research paper published by Google in 2003. And it's an example of how we made some of our research public. 2003, we've been already using MapReduce for a little while. We thought it's very useful for us. But if the bigger community starts using this, they can create much more innovative products in the internet, and this will drive the market as a whole and be therefore also good for Google. And so that's why we decided to publish this research paper, and to make it absolutely clear that we want people using it, we later granted a license to Apache to use it for Hadoop. So anything which uses Apache Hadoop is totally licensed to use the MapReduce framework. And it's not the only thing. GFS was kind of the source for it's a Google file system, and it's also the Hadoop file system is built on the research paper published there. In 2006, we published a research paper about Bigtable, which is our version of a NoSQL database, and a lot of NoSQL databases took some inspirations from that. In 2008, we published a paper about Dremel, and Dremel is what's the basis for our service BigQuery, which I will be talking about. Apache made a project, Apache Drill, about that, and that's trying to open source that. We also have new innovations. 2010 Kuehlers is our next generation file system. Spanner is our globally distributed database system, which we use for our ad serving, etc. In 2012, we published a paper about this. Last year, I couldn't choose one because Omega is so important. It's our new way to manage how machines are orchestrated and how resources are managed within Google. So it's probably the most important research paper coming out of Google in 2013, but there was also the paper about B4, which is our way of building a backbone infrastructure for a global network, which makes it really easy and cheap to copy data between data centers while using the full capacity of our network, but not losing any priority packets, having a wholly software-defined network. And this way, Google tries to innovate again and again and be a bit also experimental about technology. Only because nobody's using something doesn't mean nobody should be using it. It means we should try it out. We should try it out in a controlled setting. We should try it out with something maybe less important first, and then if we gain experience and we think it's a good thing, it's giving us some advantages, we go on and use it. And then if we think that others might benefit from it as well, we give back to the community, because that way the whole internet ecosystem improves as a whole. Yeah. Given Hadoop, and we thought about what should we do with the Google Cloud Platform. We run a lot of MapReduce jobs in Google ourselves. We have our own MapReduce framework. However, there's Hadoop. And so there was the question, what will we do? Will we run a service which is our own MapReduce and offer that to external developers, very similar to what software engineers in Google do? And we said, maybe doesn't really make sense because Hadoop has a whole ecosystem around it. There's lots of products built around Apache Hadoop. No, we want to be just the best support for Apache Hadoop as well. And we know our MapReduce runs great on our platform, so why shouldn't Hadoop? And yeah, we tried it out. Actually, on our infrastructure, Hadoop jobs run very fast because they basically use the same technology. And so when you use virtual machines on Google Compute Engine, you get some of these benefits One is that you can scale your computing and your storage independently, so you can say, okay, I want more cores to do my computations faster, but I don't need more storage right now. Or you can get huge amounts of storage, but only have a small Hadoop cluster if you only do occasional computations. You also pay by the minute, 10 minutes minimum per VM, which means if you only occasionally look for running Hadoop jobs, if you're only experimenting, you can automate bringing up a whole Hadoop cluster, and you use it for some time, and then you bring it down again, and you stop paying except for the storage you're still using. However, if you're becoming a company which uses Hadoop day to day and runs jobs all the time, and you have a permanent cluster up, we have what we call sustained use discounts, which means if a VM runs the whole month, after the month ends, you get 30% discount. Which means you don't need to before say, okay, I will need this machine the whole month or even the whole year. You don't need to like prepay anything or whatever. But if you end up using your machine a lot, you pay less. And we think this is really the fair model for the cloud. And then also we try to integrate these services with each other and create an ecosystem around it. So we try to make it really easy to set up Hadoop with Pig, HBase, and Hive, but on Compute Engine, also utilizing cloud storage and BigQuery. And I will go a bit in details because we actually built connectors to those two. Cloud storage is basically an object storage, which means it's not like a typical disk, because when you have typical disks and build an HDFS on it, well, you can lose one disk, which is fine, but if you lose 10 disks, you're kind of in a bad spot at some point, and it's not that self-healing anymore. With cloud storage, you don't have to care about any replication. You can even shut down your whole cluster, but the storage will just next time come up again. And this is what we do with the Google Cloud Storage Connector. It's just a different piece of software which you plug into Hadoop as a plugin, and you don't need HDFS anymore, and you don't need any storage nodes or name nodes anymore. You just have the master node and work node, if anyone knows about this stuff. And the other thing is you can import and export data just through any other tool which uses our cloud storage. So in Hadoop, you see it as the Hadoop file system. But also, if you have any other tool, you can use our web-based tool to upload data or to download data. So you can upload data, crunch it with your Hadoop cluster, and then you can download the results straight from your web browser, and you don't have to go through any hoops to do that. We also have a configuration toolkit for Hadoop, which is a tool which we call BDUtil, and that allows you to just, as I said, quickly bring up a cluster. You can say, I want 10 machines, 8 cores, bring them up now, 5 minutes later you can run your MapReduce jobs in them. We thought a lot, do we want to maybe allow, similar to some other cloud providers, allow people just to run MapReduce jobs as a service? And we thought maybe it's first important to let people do it quite easily themselves, because A, they can build on it, they can install any plugins and connectors and whatever they want once they have this running, and they know what the true cost is, because here you pay the true cost for the machines. For our tool, we don't charge anything. You know exactly what it costs. While if you use a fully managed service, well, you put some data in, you put some data out, you get some data out, you get some cost. You don't really know did you get a good deal or not. So we think at the beginning this is the best. Maybe at some point there will be a managed service, but for now we actually think this is easy enough to use for everybody. And just to show how well our platform works on Hadoop, our partners, MapR, who run Hadoop distribution, they did a test on Google Compute Engine in October 2012. And it's funny because just in June before, they set up a record for sorting 1 terabyte of data in 1 minute and 2 seconds. And they used 11,000 cores for that. And then MapR did it on Google Compute Engine just with 4,000 cores. And 1,000 servers in 54 seconds, so slightly faster. And it's kind of the shaving off second by second now of these records. But what was more important than just using less cores than that was actually the cost. Because the physical hardware was ordered for this and cost 5.8 million to install. And then if you run this experiment on Google Compute Engine now, you pay the 10-minute minimum, it will cost you $47. Actually, in October 2012, we still had hourly billing, so they paid 6 times that much. But if you run that now, it costs you $47 to basically sort 1 terabyte of data, including setup of the machines and bringing them down. So this just shows how now anybody has the same kind of possibilities. It doesn't need huge amounts of data anymore, huge amounts of money anymore to get something started. And you find lots of these stories on some news sites where people found some really interesting science data or some really interesting math problems, and they needed a lot of computing power quick to solve it. And now a single researcher can put in their credit card, pay tens or hundreds of dollars, and gets an insight where before he might take months and years to just acquire resources, piss many people off in the meantime. And yeah, even if it's his personal money, sometimes they get an interesting research paper out of that in very quick time. And that just shows what this is really cool about. Yeah. But if you don't want to set up your own Hadoop cluster, or maybe you have a little bit of different insights, Google BigQuery might be another thing. Now, what is Google BigQuery? It's based on another research paper called Dremel, and it's our version of a columnar data storage and analysis engine. So you upload any kind of structured data, and that's the difference. It needs to be structured data. It needs to be fit in some kind of tables. It can have nested fields, so basically for all the devs, it needs to fit in a JSON file. And then you can upload it into Dremel. And first, the data is only stored, and it lies there. And then whenever you want to do some analysis, we have a shared cluster of machines. And you can have thousands of machines. You don't even need to know. And it runs the data through a pipeline. It runs an SQL statement through a pipeline of what we call leaf nodes, intermediate servers, and root servers to get the results. And it goes through the query in parallel, column by column of the data, and that makes it very fast. And how fast does it make it? You can basically search terabytes, hundreds of terabytes of data, petabytes of data in tens of seconds. Well, like 100 terabytes, you sometimes can search in less than 10 seconds. And depending on once you join them into another, you still get results in a few minutes, where before you might have needed hours or days. So it's very fast, and it's very fast because you just have access to this huge computing power of thousands of machines. And also because they can, in that case, because it runs so much parallelized, they don't even need to use these in-memory techniques, which are very, very expensive, but it's quite cheap to run this. So what can you use it for? I just talked about that, the performance. It's very easy to use. You don't find lots of people who can do Hadoop these days. It's very hard to find Hadoop experts around who can write MapReduce jobs, etc. Although it's not really that difficult, but people who have done it for a while, it's hard to find. It's relatively easy to find people in a business context who know SQL. They have been working with SQL in any kind, in any way, and know how to use this. And now they can use it at what we call web scale for data analysis. And we provide open interfaces to that. So in the easiest part, you just have a web UI where we could put a SQL query and you get a table back. But you can also plug into an API and do the same and add your own visualization dashboard to that. And that's what most developers do eventually. In some other cases, people do very simple stuff. They don't want to use our web UI. They want to build something for the people who don't know SQL, for the executives, but they don't want to write a complex application. So we have connectors to ODBC or MS Excel or Google Sheets, and they build spreadsheets where basically every day the people can get the newest data. So the analyst builds it once, and the executive can look at it. So it's very easy to use. You can manage your database structure. You can give access to different people, and you can very, very fast import new data to the data set. It's not a full SQL database, like you cannot update rows. It's more like a data warehouse where you append new rows all the time. But you have a quite powerful SQL dialect where you can use a lot of statistical functions, etc. You can also stream data directly into BigQuery, and this is kind of what Jens Bussmann talked about. When you collect data, you don't first need to collect it in one place and then save it and somehow bring it into your data warehouse. You can just, as you collect it, row by row, you can send it into BigQuery and add it to a table whenever you collect a piece of data. And if you have a device, the device can, whenever it collects one data point, maybe every minute, it can just send it straight to BigQuery. And it allows to add up to 100,000 rows per second per table. So if you actually split among several tables, you can have even more. And the data is available after a few minutes, maximum. Like sometimes it's even less than that. So we had an example of a company in Seattle which does these smart meters, which collects electricity usage all the time, and they collect all the electricity usage, smart meter usage from hundreds of thousands of homes. And stream that into BigQuery, and they can get immediate insights on events which happen where suddenly there's a power surge in a certain part of the city, etc. So this makes it possible to do it on a city level with hundreds of thousands of rows, and it's actually quite a huge amount of data coming in there every day. Also, we see a lot of use in mobile apps and gaming, where people now can collect every kind of user action which happens, and then later use that in gaming a lot for what they call the freemium model, the free-to-play model, where you need to now get people to willingly spend their money while they're playing a game. They can very quickly analyze what brings people to be willing to spend money and what maybe not. And that way they push out updates very frequently, every few days, based on the insights they gained. And some of them find BigQuery very, very useful for that. If you want to use a mix and match of the two, you can. BigQuery interconnects directly with Hadoop, which means you can do some queries on data in BigQuery, and you can use the results in Hadoop. Or maybe more commonly, you use some unstructured data, use Hadoop to bring it in a structured way, which you can use with BigQuery, and then you run SQL queries over it whenever you feel like. And there's a direct connector as well. Also, there's a direct connector to our NoSQL database, which we use in App Engine, which is called Google Cloud Data Store. And so we want to make it interoperable between all of our tools. Google Analytics, if anyone knows website marketing, they probably know Google Analytics. And now BigQuery also has a direct link to Google Analytics Premium, which means it's the first time people can get like hit-level data from Google Analytics, and they can have the whole raw data exported straight into Google BigQuery, where they can write queries over it. And there's a lot of people who already use that to gain more insights on their website visitors. And you can do very, very complex queries. Like you can say things like, okay, who, from all the people who used the coupon when they purchased something on the site, when coming to the checkout process, who actually put in the coupon within 10 seconds, and who maybe took a minute or longer to enter the coupon code, which kind of implies they went back to a search engine and looked for a coupon code when they finally read the checkout. And so you get this newsletter users versus the guys who only check for bargains once they're there. So you can track that, or you can track how does the conversion rate go when you use load latency. And this is something we are very famous about, tracking speed, because we figured out very early in the process if our speed for our site increases, it actually increases the user interaction, and it actually increases the return. And we think it's the same for most websites, maybe not for all of them, so people can track something like that. And this is first possible now with Google Analytics Premium and BigQuery as a whole. It gives you basically for every visit, it gives you data on all the things which have been published. But in the end, you end up doing something like this, and believe me, this is a simple SQL query for people who do this professionally. I've seen people writing SQL queries like this, and this is a query which tells you what's the average time people take to go from page A to page B, which allows you to do like this coupon thing I just talked about, and it already gets to such a big SQL statement. So what we're working on now is trying to make that easier, these kind of complex queries, by using another language. And we allow, currently it's in preview, so we're testing this with a limited number of users, to use JavaScript instead to go over the data set in another way. And it makes the query much, much simpler in this way. So BigQuery will be providing performant options to query huge amounts of data, not only using SQL, but also for the more complex options using JavaScript. And this is, as I said, just now in public testing. So basically, last thing I want to talk about is, this is basically what it's all about. We want to make it easy for anyone to use big data. You shouldn't have to learn too much. If you can use SQL, you're good. If you know Hadoop, you're good. And it should be fast. So you don't need to set up your own environment for a long time. You can get results in minutes, etc. And it should be affordable for anybody. You should start. All our products have no minimum commit. You can start with BigQuery. You even get a free quota to use in our public data sets. If you bring in your own data, you only pay various little storage costs, cents per gigabyte per month, and you can try. And we want to always improve on that. We want to improve our pricing. We want to take advantage of Moore's laws, because internally it also got much, much easier and simpler to use these big data sets for anyone within Google. And now we want to open that for everyone. Okay, I'm nearly at the end. The last thing I want to talk a bit of what's coming, and one big thing is what we talk about what's up and coming in Google and big data is a technology called Dataflow. And what's Dataflow about? It's about when you have floods of data coming in and you need to do something with it. You need to transform it. And for example, you want to do this kind of auto-completion we do. You want to do auto-completion on hashtags. Let's say when people write something, what does it suggest to you? Which hashtags might you mean? So we allow that basically on a business sense. We want you to just think about how do you get there in a very, very simple way. You have the tweets, and at the end you have the predictions. And that's already the first step. You know the beginning, you know the end, you know what you want to do. And then you need to come up with just a few intermediary steps. At the beginning you want to read what you have. You have historical data. At the end you want to write the prediction. And then you go from there and you figure out how you could go along the way. So basically, if you have all the historical data, you want to extract all the hashtags maybe, and you go from the hashtags and you have a whole list of hashtags. Once you have extracted all the hashtags, you want to count them up to see which ones are the most common. Argentina was mentioned 5 million times, Armenia 2 million times, 90 million times, etc., which will eventually help you build these predictions. But then you need to build these prefixes. So when you have A, Argentina starts with A, Argentina starts with AR, Argentina starts with ARG, and it's always 5 million. And then the same with Armenia, starts with A, with AR, but then with ARM. And that way you can see how many of these it goes. So you want to expand the prefixes again. And then the next step is you only want to know the top ones. So you want to sort them the other way around. And this is basically what anyone can come up with. It's a simple flow of what you want to do. And this is how we want to have it be. It should be as simple as that. So you have these simple options you do on a certain data point, and you build simple functions around it. And we have something which is very common, which we say it's parallel do. So you do this not only for one data point, but you do this in parallel for all the data points at the same time. And then you might do something like counts, and then you run another function on top of your data. So it's actually very little logic you have to do to put this idea into a reality. Then obviously you have to write these little functions, but they're not that complex as well. It's just a few lines of code. And this is what Dataflow actually looks like. You do create a pipeline which looks exactly like the logic I explained on the slide before. And then we have a UI on top of it which actually shows how the data flows through. So how do you bring the data in? Here we bring the data in from Google Cloud Storage. It gets a whole batch of data set, and at the end it puts the output back. And you can see as the data goes through, it will actually spin up machines and optimize how it runs through the processes and how it does the transformation of the data. And it will do all this fully transparent to you. You don't need to say, I want 50 machines for this, etc. Because it doesn't really matter. You want to get through your data set, and you want to get through your data set fast. And it should cost the same if it's 1,000 machines for 10 minutes or if it's 100 machines for 100 minutes, etc. Since we bill by the minute, it doesn't really matter. So we take care of all that. And in the next step, we actually do it with data which is coming in all the time. So we expand the number of machines you need as data is coming in. So you will not only load batch jobs, but you actually stream data in and you get your transformed data out. And then historically, you can even age out the old data, that only the new data is important anymore. And this is what Google Cloud Dataflow is. We do a lot of optimization in the background. We do a lot of scheduling. We run compute engine job. We run cloud storage, but it's all transparent to you. You only need to write some simple programming business kind of logic. And it doesn't take very much to learn. Okay, last slide. Here it comes all together, everything you can use. You can use all the storage services. You can use open source product. You can stream data later with Cloud Dataflow. It's currently in a limited preview. We have something called a PubSub service, which anyone who is a developer will know. So you can push data between different services and subscribe to it. And this allows business users, data scientists, developers, and users all to work with the data. And it's kind of what we do internally these days. We use a whole bunch of tools, and you can mix and match together on what you can need. And we want everyone to be able to mix and match the same way. Cool. To get started, actually, lots of documentation on developers.google.com/cloud. For startups, we have a startup program. They can get up to $20,000 credit if they're early stage startups. To get more info about this, see me in the break or send me an email. This is my email address. And I'll be happy to send you some more information. Usually for startups, $20,000 is a lot of credit to try things out in the big data space. Most of the startups don't go through the credit in the full year. Cool. And that's it. Thank you for your time. Any questions before we break? Yes.
So, if I'm already using Apache Storm,
Yeah.
what benefit I will get if I migrate to this Dataflow?
I think the way that you use it as a service and that you don't have to care about resources anymore at all, that this might be a huge example for you. If you're already using it and you know how much resources you use, etc., then it's probably a question of cost, and you can try it out if it's more cost beneficial. Not in all cases, but in some cases. Yeah, it depends a little bit on the use case. But if you build something new, usually that you don't have to care about all these things and you don't have to set it up is a huge advantage. Any other questions? Yeah?
I have a question. So Google is all about rumors.
Yes.
I'm not talking about only food stuff here. Let's talk about, for example, search. It was said, I don't know if it's fake or not, you have some middle computers for organizing your search, and you can switch them off without any pain and so on. So, talking about these numbers and humors, so can you tell us something about your cloud solutions? So you have in millions or quadrillions? Or
No, we can't.
No, we can't.
No, we can't.
Short answer, no, we can't. We do have now, some people can get some insights, and we've been a bit more open. You can see everything which we have public on google.com/datacenters, and we've become a lot more open when basically our tech guy met our finance guy and told the finance guy, so you know nothing about our data centers because I never told you any numbers. What can you find out from our financial statements which we put in the public? Everything our finance guy found out, we made public anyway. So also any data center you can see from space, it's on the data centers page. So it's like we try to be a bit more open. We generally think we still have competitive advantages in many spaces, so we're not as open as some other companies are. Yeah. Any other questions?
Yeah. So you mentioned Google Omega project,
Yeah.
and you also have this Kubernetes project.
Yeah.
So as I understand, right now Kubernetes is like very stripped down version of Omega, very simplified. So are you planning to bring any advanced stuff from Omega to Kubernetes over the time?
Kubernetes is coming in my next talk. So Kubernetes is basically a new development using only open source libraries and not using anything we only use internally. Also using other open source technology like Docker. So it's not a one-to-one port of Omega, and we started this project. We brought it out to the public very early, just because we want to get others to contribute. So you can expect a lot of new changes around Kubernetes, and this to catch up very, very quickly. We will probably not this year replace internally Omega with Kubernetes, for example. But the idea is that this becomes a leading framework that anyone can use, any size. Yeah.
So you said $20,000 for free for startups, right?
I said $20,000 credit. Credit. I don't have cash with me.
But where is the catch?
Where's the catch? There's no catch in that. We do wanna. It's actually not from our cloud group. It's from the Google Developers Relations group, whose goal it is to bring startups to grow the innovation theme. And basically, a bigger internet ecosystem is a better thing for Google in general. So we want to help startups on the way, and to help them use our technologies as well, to get used to our technologies, and it's a very long-term thing. So in this 1 year, there's no catch at all.
If you qualify.
If you qualify.
If you're still a startup, if you're already funded with millions of cash from investors, you're not qualifying. Yeah.
Okay. Any other questions? Well then, thank you and enjoy your break.